Okay, so welcome to our first Spin Developers Community Meeting. This will happen every month on the fourth Monday of the month. And we wanted to start getting everyone together to touch base on what we're working on, what is new. And on that, we're going to start off with a demo of a new feature. So let me run the demo.
Hi, Internet friends. In this video, we will see a short demo of using Spin to build an application that uses the new key value API and how to satisfy that API using a local SQLite file, the default implementation in Spin, your own instance of Redis, an Azure Cosmos DB account, or Fermion Cloud. Let's dive into the demo. Here we have a Spin application with two components. The first one is a counter component that for each request will increment the value of in the key value store. It has access to the default key value store. And then the second component, it's a pre-built component of the Spin Key Value Explorer that lets us introspect the contents of a key value store. And it has access to the same default key value store. In addition, our counter component has a component build section that contains a build command. Whenever we run spin build, this command is executed, and then it has a watch configuration so that every time a file that matches one of these patterns is changed, if we run spin watch, Spin can automatically rebuild and restart our application for us. So let's dive into the source code. So this is a TypeScript component. Here we import a Fermion Spin SDK, and then our handler function is a function that takes a request and a response builder, and we can open the default store, try to load the data and deserialize it, increment the value of our counter, save the new value to the store, and then return the HTTP response with the updated value. So we can do a spin watch, and then the key value store has credentials. It's a basic HTTP authentication, and I'm setting the values here. And when we do a spin watch, initially Spin will start the application, count is 20 something. If we go back to our source code, save it, spin watch detects that, rebuilds the application, restarts it, and we now are running our updated application. If we look closely at the logs, you'll see that it's storing default key value data to a SQLite database file. This file can be found in the .spin directory, and this is where Spin will, by default, keep the key value data. This is great for local development, great if you don't care necessarily about having a persistence across instances, but what if we want to run this and actually have that persistence? So because we're using the key value API in Spin, we can back that using different implementations. So with no additional configuration other than this key value stores section, let's deploy our application to Fermion Cloud using the same key value credentials. And essentially, Fermion Cloud has a default implementation for that key value API that is highly available and implemented in Fermion Cloud. We're now waiting for the application to be deployed, and count is 1. Hello, universe. So we can refresh that, and that data is available in Fermion Cloud. We can also look at the key value explorer. Execution count, same value that was here last time. We've seen how to run an application locally. We've seen how to deploy to Fermion Cloud with no configuration changes. But what if we want to store that data in a different place and we don't want to change anything about our application? This is where Spin's runtime configuration option comes into play. Let's have a look at this runtime configuration. We're saying that for the default key value store, we want to use a Redis backend, and we want to use this URL for our Redis instance. This is a local Redis instance, so let's start that. It's now ready to accept connections, so we can do spin up. And the only additional thing we need is specifying the runtime config file and running the Redis runtime config file. So let's expand this a little bit and start it. And we are now storing the key value store for our default store in Redis. So and then if we look at the Explorer, execution count is 5, which is what we saw there as well. But that's not all. there's in 1.2, we have an additional configuration option for the key value store based on Azure Cosmos DB. And essentially, we specify Azure Cosmos, the key for our account, which by the time you're watching this has been changed, our account, database, and container. And in similar fashion, all we need to do is, instead of passing the runtime config Redis file, we're passing the runtime config Azure file, and our application is now storing our default data to Azure Cosmos DB in the SpinKV account, SpinKV DB database, and SpinKV container. And this is now running in Azure Cosmos DB. And if we start the Explorer, we can now see some metadata, some ops about our application, and we're now seeing the round trip to the Azure data center. And if we go to our Azure portal, we can actually see that the execution count and all the values that we could set. If we go back to our key value explorer and, for example, delete the execution count and go to Azure portal, that is now gone. So if we start the counter again, now it's back to 1. So we've seen how to build a Spin application that uses the Spin key value API. This is based on the WASI key value proposal that's being discussed in the WebAssembly community, and see how to build that application using the local built-in SQLite implementation, deploy that to Freeman Cloud with no changes, and then run that using your own Redis instance, again with no changes, or bring your own Azure Cosmos DB account and essentially have control of your data using whatever backend you might need. Thanks.
Hey, it looked like the sound and video got a little off on my end, so hopefully you guys got a good a good demo out of that. So any questions or comments? Oh, it looks like chat is active. So anyone want to raise their hand with any questions or comments? Okay.
I'll preemptively say that the Azure Cosmos DB key hasn't been changed. So
all right, awesome. Okay, so with that demo, if no one has any questions or comments on that, then we'll move on to our announcements. And for that, I'm going to start with Joel and pass it to him.
Hi, everybody. So the announcements are maybe in reverse chronological order in the agenda, but I'll go ahead and go through them in roughly chronological order. Starting with release 1.3, Spin 1.3, we're planning to get that out early June, so just a few weeks from now. And the two big things at this point that look to be in that release are color-coded output, so kind of just fancy colored output from spin up and other subcommands, hopefully make it a little bit easier to read and see, distinguish between different types of output. So that'll be coming along. And then the other big one is cloud support, cloud plugin support. For a while, we've wanted to kind of decouple things that were Fermyon Cloud specific from Spin, and converting the things like Spin Deploy to the cloud to a plugin is part of that vision. So I'll let Kate go into some detail on what that looks like.
Sure, yeah. So as Joel mentioned, we've had a plugin system for a while. And the part of the reason for that system is so that we can keep Spin core and the necessary functionality of Spin as specific to what you need just from Spin. And you can think of Spin login and Spin deploy as a bit orthogonal to the Spin runtime itself, and more about packaging and distributing your application. And so moving those two commands out into a plugin, namely a plugin called Cloud, would make that Spin functionality as slimmed down as possible. And so what that'll look like is you'll still be able to see Spin deploy and Spin login from the CLI help menu. So it'll look the same. The only difference is that Cloud will be an installed plugin. And so if you're building from source, that would mean that you'll be prompted that on your first login or deploy, it'll say, hey, you need to install this, and it'll install it for you. And otherwise, we're hoping to update the install script so that you automatically get that plugin with the install script, which seems to be the main way that people are installing Spin. And then on a next step of that, we'd like to distribute Spin with package managers. And so then the package managers could also come with this cloud plugin. And as Roddy put in the chat, there is a PR open with the implementation of moving that functionality out. And it also has a SIP kind of discussing kind of the reasoning behind it and what that experience will look like.
Cool, thanks, Kate. And speaking of plugins, that plugin to enable WebAssembly based plugins, or it looks really cool. I'm interested in playing with that. Thanks for contributing that. That's something we've been talking about for quite a while as well. It's definitely makes sense. WebAssembly and plugins, it's like, they go together. It's a pretty natural fit. So let's see, next item, SQLite. Ryan on our team has been working on this. Essentially, it's a natural progression from the default key value implementation that we have in Spin, which is SQLite based, as Radu mentioned. Once we've gone that far, we might as well open up the full power of SQLite. And so that's what we're planning to do. There's a SIP and now an implementation in the main branch of Spin. We're thinking that probably won't go into the 1.3 release at this point, because there's still some open questions, especially regarding how to support very large result sets from SQLite, especially in a memory constrained environment such as we tend to have, in a serverless context. So if that all doesn't get worked out in time for the release, we'll hold that till 1.4. But it's ready for feedback at this point if you've got thoughts or ideas. And then finally on the agenda here, also aiming for 1.4 is the next stage in component model support. If you've been following the work in the WASI world from the Bytecode Alliance, you may know about what Spin calls components are not really components in this grand vision of what the WASI component model is all about. And we quietly introduced, as of Spin 1.1, true component support as an experimental feature, so you can now actually run true WASI components in Spin. However, you kind of have to know what you're doing to do that. The official SDKs won't actually give you components by default. They'll give you what are called WebAssembly core modules. And so we're trying to get closer to the point where you can actually produce true components using the Spin SDKs. And part of that involves updating the fairly ancient version of WebBindgen that we're currently using for the SDKs, including the Go and the Rust and our experimental Python and JavaScript SDKs. So that's what we're aiming for 1.4, is to actually get the WebBindgen version updated across the board. That in theory, that should not change anything at the source code level. Everything should work as you're used to. You shouldn't have to. You can rebuild these in the new SDKs without any code changes, but it will. One of the nice things about that, for those who are interested in writing their own trigger plugins, this is going to make that a lot easier, because at the moment we have this dichotomy between, we've got the old .wit files, which the SDKs use, and the new .wit files, which the host implementations, host components use. And especially when you get into trigger plugins, that becomes awkward. And so in any case, for 1.4, we're planning on using the new version of WebBindgen across the board for host and guest. And that should no longer be a pain point. And then later on down the road, not sure exactly when this is going to happen, we hope to have true native stable component support in Spin, but that essentially needs to wait for WASI Preview 2 to be stabilized and released before we can really call that stable. That's currently aiming for maybe August, September timeframe. There's a lot of work that needs to be done before that, but that's what we're shooting for long term. And I think that's all I have. Any questions about all that? All right, I'll hand it back to Melissa.
Thanks, Joel. Okay. Okay, so the next item on our agenda is our call to action. So Ivan, can you tell us about that one?
Well, I think Joel has told us about it already, really. So this is the SQLite feature, which we are currently working on in main and is likely to land in 1.4. We've got an implementation there based on an initial design that is, or initial interface that's kind of aligned with WASI SQL. It's not identical because WASI SQL is still not quite there. But we're looking at some sort of design considerations there. So I've linked to the existing SIP, which is 013. That's a little way up in the chat. But there are some open questions in that, and we are reviewing in particular the query design. And again, there's a link in the chat, pull request 1534. It would be really great if folks could have a look at the SIP and look at those changes that are being discussed and give us feedback on that, on the considerations for them as consumers of the API, and how they see that fitting into the broader WASI SQL community. So if you've got time to have a look at that, that'd be really good. Thank you.
Great, thanks, Ivan. Okay, so the next item on our agenda, we just have an open floor for anyone with comments, questions, things they would like to discuss. So the floor is open. Go ahead and raise your hand if you have anything you want to bring up.
Yeah, I guess I have a question. So I'm still kind of understanding, the difference between core modules and components. And like, could someone, I don't know, like describe the biggest benefit that will come, maybe long term or short term?
I can take a stab at that. One of the big benefits here is the shared nothing architecture that sort of underpins components, and in particular that makes it easier to create polyglot components, if you will. So a single piece of functionality, a single serverless function, if you will, or whatever the problem domain is, which could have, say, a router written in JavaScript and a cryptography component written in Rust and some other piece written in Go, and being able to basically compose those together as a single unit of deployment and execution has some appeal. So there's that aspect. There's also, because of that shared nothing architecture, a level of security sandboxing that you don't get from, say, statically linking everything together into a single core module. For example, one of our visions is, say you have an endpoint that needs to handle sensitive information such as credit card numbers or something like that. The idea that you could compartmentalize the parts of parts of your component that actually need access to that number and prevent any possibility for that of that leaking into other components. So essentially a heterogeneous set of privilege levels within an execution unit is part of the goal. There's a lot of others. We've actually been brainstorming ways we can demo kind of the power of components lately, and we've got a few things that we're going to try and put together. Another is virtualization, basically creating virtual file system layers, kind of similar to what a virtual machine or a container type of runtime would give you. And some of these virtualizations could have nothing to do with a real file system. They could be backed by a key value store, for example, but creating the illusion, basically adapting the ability to adapt a component that was intended to be executed in one context and executed in a different context where the same resources might not be available. So anybody else have anything that comes to mind?
I do think that pretty well covers kind of the key advantages. I wanted to explicitly spell out kind of the building blocks that gain these advantages. One is, Joel already mentioned, the shared nothing linking as a really key part, but the linking in there is also something where the component model contains a design for basically defining which components get linked together, where currently in Wasm-Time, for example, you can have the linker object and can create graphs of components, but it's always kind of from the outside and it's not contained in the components. What they don't tell you what they should do, and the component model brings module linking as one part, or component linking. And then the other bit is a foreign function interface that is polyglot and high level. So you can very efficiently pass around high level data structures from strings to structs to tuples to lists. And with async in the future, also streams and futures or promises, and that without exposing memory. With core WebAssembly, again, this goes to the shared nothing linking. With core WebAssembly, if you want to pass anything but just individual numbers in parameters or return values, then you have to expose your memory or import another module's memory. And with the component model, both of the components that want to communicate with each other can still stay fully encapsulated and not expose any of their memory for security reasons, but also for interop reasons. They don't have to tell each other how their memory is laid out, how their data structure is laid out. That's all stuff the runtime does for the components in play.
Awesome, thanks.
Okay, any other questions or discussion topics? All right, so at the end of the call, we just want to give anyone an opportunity to say hello, tell us what you're working on, what your interest in Spin is, and just introduce yourself to the community. So would anyone like to introduce themselves?
Yeah, I can go. So, hey, I'm Steve Sloka. I work for a company called Outerbase. We do some database things. I think I've talked to most of you or half of you on the call. So thank you all for your help. I've just been learning Spin, and we're looking to use it for some fun things with databases. So just digging in. I know it's all new. It's new for me, a lot newer for me than it is for you folks, but just want to say, hey, thanks for all your help and chatting on the Discord. So that's all.
Great to see you in person, Steve.
Yeah, you as well.
Great, thank you.
I guess I can go. So I'm Matheus Cardoso, basically contributing to the project and learning out of it. So like the idea of using any language to build like a performant and decoupled services, and basically not having to deal with Kubernetes in the future or or Docker or anything like that really fascinates me. So I've been trying to learn and contribute a bit.
Really great to meet you. Spinlet is really cool. Thanks for prototyping that.
My pleasure.
All right, anyone else before we wrap up the call? All right, great. Well, thank you everyone for a wonderful first Spin Developers meeting, and we hope to see everyone in another month. Bye, everyone.